We begin our study of algebra with what many mathematicians would say is the most fundamental notion in mathematics, the notion of a set. Now, for our purposes, we're going to think of a set as just a collection of objects. Now, this definition is highly informal. If we're going to do anything really complicated with sets, we would need to make our definition of a set more formal, more precise. But for our purposes, a collection of objects is enough. If an object is in the collection, we say it's an element of the set. Just a little bit of notation. Typically, to describe a set, we'll use capital letters, and then we'll use lowercase letters to describe the objects. So capital letters will represent sets, lowercase letters will represent objects. That's not a rule, it's just what we'll typically do. When we say an object is an element of a set A, we'll use this symbol to mean is an element of. When we say an object is not an element of a set, we'll use this symbol to mean is not an element of. Now, how can we describe sets? We have a variety of notation that we use to describe sets, but the simplest notation is what's called roster notation. In roster notation, we just list all of the elements of the set enclosed in these curly braces. So to write these by hand, we have kind of a capital S and then a capital S backwards. For the close bracket, a capital S backward, and then a capital S. If you look on your keyboard, on a standard keyboard, these are on the keys that are in the top row just to the right of the letter P. So here's an example of roster notation. The set A here is indicated to be the set containing just the numbers 1, 2, and 3. If we have a pattern to the numbers in a set, we can use this 3 dot symbol to indicate a pattern that continues. So if we say that B is the set containing 1, 2, 3 dots, 20, that means that B contains the whole numbers, right? That is just the counting numbers, 1 through 20. We can indicate slightly more complicated patterns. So if C is the set 0, 2, 4, 3 dots, 100, that means that C contains the even numbers starting at 0 and going up through 100. We can also use the same 3 dots to indicate a pattern that continues forever. So if we let D be the set 1, 3, 5, etc., that means D is the set that contains all the positive odd numbers. So just as a quick exercise in using this notation, we have 3 sets here. A contains the numbers 1, 2, 3, 4, 5. B contains the numbers -3, -1, +1, +3. C contains the numbers 3, 5, 9, 11, etc. I think this is a typo. I think 7 is also supposed to be in here. 3, 5, 7, 9, 11, etc. So we can fill in the blanks to say whether certain numbers are or are not in each set. So the number -1, right? -1 is not in the list for A. So we write this element symbol with a line through it to mean -1 is not an element of set A. We see -1 in set B. So we say -1 is an element of set B. -2 is too small to be in set C. So -1 is not an element of set C. The number 2, we see that here in set A. So 2 is an element of set A. It's not in B. So 2 is not an element of B. and then it's too small to be in C. 2 is not an element of C. And then the number 3, well, we see the number 3 in all three of these sets. So 3 is an element of A, 3 is an element of B, 3 is an element of C. So that was just some quick practice of looking at roster notation and seeing if a number is in there, and then using that element or not an element symbol.